We can find the rise and the run by completing a right-angled triangle. If we count the squares along the rise and the run and find the ratio, our answer would be 2. Therefore, the gradient of the line would be 2. If we did the same for 3y equals 9x minus 12, we would get a value of 3 for our ratio. Therefore, the gradient is 3. Remember, we simplified the equation to y equals 3x minus 4. What do you notice in both equations and the values obtained for rise over run? The gradient is that number or coefficient of x in the equation of the line. This is denoted by the common letter m. Notice that the rise is the change in the y values and the run is determined by the change in the x values. A change in values would suggest that we subtract values. Therefore, the gradient equals rise over run. The rise over run equals change in y values over change in x values. And this is equal to y1 minus y2 over x1 minus x2. So if we are given any 2 points on the line, we can find its gradient. Let us use 2 points from the line y equals 2x plus 7. How about negative 2, 3, and 1, 9? The gradient would be 3 minus 9 divided by negative 2 minus 1, which is negative 6 divided by negative 3 equals 2. This is the same 2 in the equation y equals 2x plus 7. An important thing to know about gradient is that if its value is positive, the line will slope upward from left to right. And so if the value is negative, it means the line slopes downward from left to right. For example, in the equation y equals negative 2x plus 2, the gradient is negative 2. Okay, now let's look at both lines again. Where does the line for y equals 2x plus 7 cross the y-axis? At 7 on the y-axis. Yes, the same 7 that is in the equation y equals 2x plus 7. And for 3y equals 9x minus 12, the same equation as y equals 3x minus 4, the line crosses the y-axis at negative 4. The point where the line crosses the y-axis is called the y-intercept. It is denoted by the common letter C. Note that when you intercept something, you cross it. The same thing applies here. This is what gives us the general equation for a straight line, y equals mx plus c, where m is the gradient of the line and c is the y-intercept. So, if I give you the coordinates 4, 17 and negative 4, 5, can you tell me what the equation of the straight line is? First, we need to find the gradient of the line. Remember, it's the change in y divided by the change in x. This would be 17 minus 5 divided by 4 minus negative 4, which is 12 over 8, or 3 over 2. Yes, our gradient may be a fraction. Now that we know what our gradient is, we can find out what our y-intercept is. We use the general formula for the equation y equals mx plus c. We substitute 3 over 2 for m, and we choose any one of the coordinates and substitute for x and y. Let's choose negative 4, 5. So in y equals mx plus c, we substitute and get 5 equals 3 over 2 times negative 4 plus c. Since c is the only unknown, we solve for it. The solution is 11. Therefore, our equation is y equals 3 over 2x plus 11. So now we know how to determine the gradient and y-intercept of a straight line, and thus we also know how to determine the equation of a straight line. What do we mean by volume? The volume of an object is the amount of space it occupies. And so it follows that the object that occupies more space is said to have a greater volume. Which of these objects occupies the least amount of space? You can't tell just by looking, but you can find the answer by comparing the volume of each object with a standard unit. The standard unit for volume is a cube with each edge measuring 1 centimeter. We call this 1 cubic centimeter. Let us find the volume of a prism. But first, let me ask, what is a prism? A prism is a solid which has a uniform or constant cross-section. That means that the shape and size of the cross-section does not change. The cross-section is usually taken as the base. Can you think of any solids which have a uniform cross-section? Examples of solids which fall in the category of prisms are the cube, cuboid, cylinder, and wedge. Let's look at how to determine the volume of each of these objects. Let us use a cuboid which has length 7 centimeters, width 4 centimeters, and height 5 centimeters. To understand what the volume of this cuboid is, let us fill the bottom of this prism with unit cubes. This means the bottom of the cuboid will be like a box and will hold as many cubes as possible without placing them on top of each other. This is not yet the total volume. It is only a part of the total volume. We could count these cubes to find the volume that is there now, or we can use a shortcut. Since the length along these cubes is 7 units and the width is 4 units, this layer of cubes measures rows and columns that are 7 units by 4 units. So we know that there are 28 unit cubes in this layer. This is also how we find the area of the base, which is a rectangle, length times width. If we were to stack cubes on top of each other until the prism is completely filled so that all the cubes are touching each other and there is no space between them, we could therefore find the total volume by counting all the cubes. To count all the cubes, we already know that there are 28 cubes in the bottom layer and all layers have the same number of cubes. So we only take the bottom total of 28 and multiply it by 5 because there are 5 layers in the prism. 28 times 5 equals 140 total cubes. So the volume of the prism is 140 unit cubes. If we take a look at our calculations, we see that the bottom layer of cubes was found by finding the area. That is, by multiplying the length by its width. We took this result and multiplied it by the prism's height. So the volume of the prism is the area of its base times its height. This applies to all prisms. So it is really just a matter of identifying what shape is at the base of the prism. So if a matchbox has length 5 centimeters, width 3 centimeters, and a height of 4 centimeters, what is the volume of that matchbox? We know that the matchbox is a cuboid. So the base of the cuboid has a rectangular shape. We first find the area of this base by multiplying the length by the width. This gives us an area of 15 centimeters squared. The volume would then be found by multiplying this area by the height, 4 centimeters, to give 60 centimeters cubed. If a die has an edge of 2 centimeters, what is its volume? We use the same approach to find the volume of the die. We know that the die is a cube, so the area of the base would be length times length, which is 4 centimeters squared. The volume would therefore be 4 centimeters squared times 2 centimeters, which is 8 centimeters cubed. Again, the approach to finding the volume of a cylinder is similar. First, identify the shape of its base. What is that? It is a circle. So we find the area of this circle and multiply it by the height of the cylinder. If a cylinder has a diameter of 14 centimeters and a height of 14 centimeters, what is its volume? The area of the base is found using the formula for the area of a circle, pi times r squared. If the diameter of the cylinder is 14 centimeters, it means that the radius is 7 centimeters. The area of the base would therefore be 22 over 7 times 7 centimeters times 7 centimeters, which is 154 centimeters squared. The volume of the cylinder would be found by multiplying this area by its height, which gives us 2,156 centimeters cubed. A wedge is also known as a triangular prism, and as the name suggests, has a triangular base. So if we are going to find the volume of a wedge, we first need to find the area of its triangular base. Did you know that a pyramid with the same base and height as its corresponding prism is 1/3 the volume of that prism? A square-based pyramid has a base with side 5 centimeters and height 10 centimeters. The area of its base would be 5 centimeters by 5 centimeters, which is 25 centimeters squared. So the volume would be 1/3 of this times 10 centimeters, which is 83.3 centimeters cubed. The formula for the volume of a cone can be found from the formula of its corresponding cylinder. Let us look at a cylinder and a cone which have equal heights and radii. It would take 3 of these cones to fill the cylinder with water. This means that it takes the volume of 3 cones to equal the volume of 1 cylinder. Looking at it in reverse, the volume of the cone would be 1/3 the volume of the cylinder. Since the cylinder's volume is area of base times height, then the volume of the cone is 1/3 of the area of the base times the height. This same relationship exists between pyramids and prisms. If we were to use a pyramid and a prism with equal bases and heights, we would find the exact ratio of volumes. It would take 3 pyramids to completely fill a prism. A cone has a base radius of 10 centimeters and a height of 14 centimeters. What is its volume? The height being measured here is the perpendicular height, the same height that would be measured in the case of a pyramid. The area of the base is 3.14 times 10 centimeters times 10 centimeters, which is 314 centimeters squared. The volume would therefore be 1/3 times 314 times 14, which is 1,465.3 centimeters cubed. An orange has a diameter of 10 centimeters. How would we find the volume of this orange? The orange is a sphere. The volume of a sphere equals 4/3 times pi r cubed. So the volume of the orange is 4/3 times 3.14 times 5 centimeters cubed, which is 523.3 centimeters cubed.